In your Trebuchet report, under the results section, I ask you to show an example range calculation. So I want you to step all the way from the beginning, the potential energy of the counterweight, all the way to how did you calculate the range. You guys did this in two different worksheets, conservation of energy, and then the projectile analysis worksheet, and you also created an Excel table. Now you don't have to get real detailed, but I want you to walk me through where did the potential energy come from? Why do we have potential energy in this system? And you need to remember that this mass is the mass of the counterweight. This is acceleration due to gravity, and h is the height that your counterweight changed in. So you've already found these things. You already have your mass in kilograms. Just use one of them. This is an example. So whatever one you want to, maybe you even just make one up and put like 1 kilogram. I would probably use one of the numbers that you already have up here in your Excel. So for potential energy, you have mass of the counterweight. So choose this one, for instance, whatever it happens to be. Maybe it's 1 kilogram. Take it times gravity, which is 9.81 meters per second squared, and then take that times your change in height, which is right here. They're all the same because you didn't change that at all. The next step was that the potential energy from the counterweight was converted into kinetic energy. And so for that equation, you took 1/2 times the mass of the marble. Mass of the marble, because that is what you're throwing, times the velocity squared. Thing was, though, you don't actually need this equation because all of the potential energy is converted to kinetic energy. So you want to say that in your report. You can say something like the energy for the catapult came from the potential energy of the counterweight. As the counterweight fell, all of that potential energy was converted to kinetic energy. Boom, that's how I got my kinetic energy. Then to find the velocity, you rearrange algebraically this equation for kinetic energy. So potential energy and kinetic energy are the same. This is the mass of your projectile. Rearrange and you can solve for the velocity. The reason why you got the velocity is because you needed that to then find the range. Your range is calculated with this equation. Theta, this 0 with a line through it, that's the angle that you fired at. G, that's the acceleration due to gravity. All these terms were defined in your worksheets. So if you went back, for instance, to conservation of energy, all of the things are described on that worksheet. And then let's see if I have, yes, projectile analysis, same thing, 9.8 meters per second squared for gravity. So I just want you to simply step through how you did those calculations. Now, another thing you need to do is use Microsoft Equation Editor. That's how I made all of these equations. So what you do is insert equation, and then you can start typing out underneath design here. They have all sorts of symbols, all sorts of different types of fractions, subscripts, trig functions. It has everything. So maybe I'll do the hardest one right here on this range equation. I'm going to change it up actually. I'm going to make it range ideal. Notice I made that subscript. I just used that box. If you want to do a superscript, you do this. I don't know what case you'd use this. You have a subscript and a superscript, probably calculus. Okay, equals. And you got to kind of plan ahead because you've got to do the fraction right at the beginning here. So you have a fraction. You have velocity squared. So you got to think ahead again. You're going to have a superscript. Then times sine, and it'll get stuck up here on that 2. You got to kind of click down here until it becomes big, and you're no longer up in that superscript anymore. So here's your sine function. and then it's 2 times theta, and theta should be right. Let's use, actually it doesn't really matter too much. You might want to use that one. Whatever matches the symbol up here best, that one would probably match that best actually. Underneath the F gravity. So it's that easy. What I want you to put in words is we had an input of energy in the form of potential energy from the counterweight. We took the mass of the counterweight times gravity times height. Put those numbers in, example numbers. Show that you found the potential energy. Then tell us why the kinetic energy is equal to potential energy. Because energy is not created or destroyed. It's just being transferred in this case. Then show me how you rearrange this to solve for the velocity, and then plot that into this equation here. So you're just going to step through the casual reader. How did you calculate all these different things? It's not that big a deal. And this equation editor, let me know if you need help. But it's really nice tool to be able to use.